And in all those great presentations, there's so much amazing detail, a lot of great storytelling along the way. Some of them are amongst the best presentations I've ever heard. So you're in for a treat today to hear all this great stuff. But a lot of it, if you're new to the world of 2110 or thinking about going to the world of 2110, might seem a bit daunting. So many of the presentations here are geared for those who already know 2110 and want to further their knowledge, that kind of thing, or are perhaps already experts and want to increase their knowledge even further still. But for those of you who are watching, either in attendance or out in the streaming world, who might think, I'm just really kind of an SDI person, I just want to get into this, and there's a lot of detail, and up to and including Conor's great presentation moments ago, where we're talking about programming this, you know, we've probably all been to our friends' homes or relatives, and some kid built a water-cooled computer to run their favorite game, built from scratch. But somewhere along the way, most of us keep our lives going by sending emails on laptops. So there's the world of 2110 for those who want to build everything themselves and program it to the nth degree. And there's people who want to simply do a plug and play. Both of those worlds exist. My job today is to introduce to the world of the plug and play 2110 ecosystem and how that works. Okay, so we're going to start with a little bit of fun though. So you saw some details in Conor's presentation, and a lot of technical details will follow in the other presentations. And here is a neat little specification about the world of digital video. So for those of you that want to read through all this kind of stuff, it's pretty interesting and super talent complex, super deep, and probably not something most people, again, emphasis on most people, have never thought about. And as a result, you think, boy, this is really daunting now. Right off the bat, I don't know if 2110's for me. I just like my plain old SDI. It's super simple. I don't have to deal with any of this kind of stuff. Well, psych. This is actually part of the SDI specification. So for any of you out there, which is probably just about everybody watching, if you're interested in converting to 2110, have ever put together an SDI system, a camera to a monitor, a full router, switcher system, all that kind of stuff, it's unlikely you've ever thought about this at all. It's probably likely you don't even know this existed, because you didn't have to know this. You simply plugged in one coax cable with B and Z connectors from your camera to your monitor, and away you went. Maybe a little configuration here to make sure the output was set correctly or whatever. But you didn't have to know this level of detail. The same thing is true of 2110. If you want to get to this level of detail in the version of the 2110 spec, that's great. If you don't want to, if you just want to build a system and get on with the rest of your life, that's great too. So, it doesn't have to be super technical. So let's start with a recap of some of the great things that Conor mentioned in his presentation, why we want to go from the world of SDI to 2110. I imagine there's few people out there who are going to get into video from the get-go and jump straight into 2110. Most of us are going to migrate from the SDI world to 2110. So, what does that mean? Well, a comparison. That's what we love to do in just about all things in life. So we've got all kinds of things about why 2110 was invented, essentially to overcome the shortcomings of SDI. So cable length, the cost of the cable itself, everything from the fact you could send signals in both directions, loads of great things when it comes to the idea of reference being included and not a separate signal altogether. On and on the list goes. This is sort of like our top, 7 list of why people like to go 2110, why it was invented in the first place. So keep an eye out for these kind of details and benefits as you go through your journey into exploring 2110. But again, it exists because SDI wasn't perfect. So there's always a goal in our industry to make things better, more expandable, less expensive. All those kinds of things drive just about all innovation, and in particular in the television industry. So these are some of those reasons. So let's take a look now from a practicality standpoint, and we're going to harken back to the grand old days of SDI, which is basically today, and going backwards all the way to 1989, which is in fact when SDI was invented. And a fun little pause there. How many things in the production world that you engage with today were invented in 1989? Your switcher, maybe? Are you running a video wall comprised of actual monitors in a wall and all that sort of thing? Probably not. Do you have a linear editing system that you use to create all your content? Seems unlikely. Not many things in the world we use today were invented in 1989. But SDI was, and it's been moved along, kind of improved a little bit here and there incrementally to the point where now we have 12G and fun things like that. But again, it's kind of long in the tooth. Hence, once again, a new kid on the block, ST2110. But let's go back to this example of SDI here. We got a router in the middle, cameras at the top, some displays at the bottom. And to connect things up, it's pretty straightforward. Most of us have done this to some extent or another, where we basically connect our SDI sources to SDI destinations, and away we go. Let's hook up a router control panel in this case, and we'll get some routes going and make ourselves some cool pictures. Really couldn't be easier. 4 cables, plug it in, a little router control panel to tell what signals go where, and you're set. Nice. Doesn't seem like there's much of a way to improve upon this. Well, let's go ahead and take a shot at it. Now we're going to look at the ST2110 equivalent. So instead of a router in the middle, it's basically a switch. So forgive me now, because one of my favorite things to do when teaching people about video in general is one thing has 10 different names, and 10 different things all have the same name. So you just have to get used to that in the television world. And here we are that we have a switcher. There's also a switch. And what does the switcher do? It switches things. So forgive me for having to muddle all those words together here. But a 2110 router is in fact just a switch. Now, the first thing we're going to do, unlike our SDI example, is we're going to put in some stream IDs, an IP address for the various multicast streams that we're going to have. So one for the 2 cameras, one each, I should say, for the 2 cameras, and one each for our 2 displays. And now that we've got those details entered, we're going to put in something called a port number as well. It's a set it and forget it type function, to quote an infomercial term. Once we set those multicast addresses and the port numbers, we really don't have to worry about it again for the most part. All right, now that that's done, we'll connect up our wonderful control panel, just like we did in the SDI days, and we'll make our routes. And yay, everything's looking good. Now we've got some images and all that stuff. All right, so seems kind of like the SDI world, except we had to type in all these numbers, all these IP addresses. So you could say, thanks 2110 for making it a lot more work to do what SDI did quite simply. But of course, that's just the first part of the story. Circling back now to our SDI simple or traditional example, if you will. I was shorthanding before because, of course, if you're going to have cameras, you're going to have blackburst, and you don't forget about return video. Maybe there's more than one return video. You might have teleprompter, all that sort of thing. So those are all separate signals, separate cables that you'll need. And if you want to, by the way, I should say, if you want to strip off audio from one of those sources, it doesn't really happen in the router. SDI routers don't do that. You need to take that signal out of your router, de-embed the audio, because it's on a frame-by-frame packet basis, and now put that audio in its way. I've been to some great stations around the country that have $1 million router with the most elegant cable management you've ever seen. It looks nice as can be. And then there's about 20 simple converters breaking out your audio, hanging off, almost dangling there, just by the SDI cable holding them up. Not super elegant. And those converters, if you will, those de-embedders for audio, probably $150, hooked up to $1 million router. So you could say that there's not really a nice match there in terms of how all this works. And so that's just part of what you have to do in the SDI world. Okay, and again, your audio comes out. So, nice. All right, so now let's take a look at a situation where I've got, if I'll direct your attention to the upper right there where it says input number 6, camera 2's output goes to input number 6 on my router. And then, for a collection of reasons too long to list, somebody goes and changes the patch. And now the output of camera 2 is no longer going to input 6, it's going to input 5. So, happens all the time. Doesn't seem like it should happen. Who knows why it happens, but it happens constantly, unendingly, unceasingly. People change things for reasons that nobody understands. But in our case, what happens to that signal that's going into output 6 to our monitor? Well, of course, it goes away. The SDI router, all SDI routers don't understand that someone disconnected their source. They just know that there's no source there. Oh, well, it doesn't know that same signal's now been moved over to input 5. How would it know that? It doesn't know the original source, if you will. How would it know that? It's just not part of how SDI works. So you end up with no image. Then, of course, you have to go suss it out, look for the patch or the connection that was pulled, whatever it was. Now, that's just part of what you deal with in the SDI world. Again, how would you know where that signal is? How would you then somehow have some magical intelligence inside the router to go find that new connection? You just can't. That doesn't work. All right, now let's go back to the 2110 world. So for starters, we can say that, all right, besides the idea of having our audio and our video and all that kind of stuff, we can also have PTP and essentially everything we need in a single cable. No longer, in other words, in comparison to SDI, do we need a separate cable for reference and a separate cable for return video and a separate cable for prompter. All of that goes over our wonderful 2110 connection. And in fact, I made a little change there. Unlike a traditional SDI router where every connector is either in or an out, in the 2110 world, because it's a network switch, they're in and out, bidirectional. So now I can basically take signals from our sources and send signals back to the sources. I don't have to have loads and loads of cables. And in the case, if you had a lot of cameras, you would have saved a boatload of cables and simplified the process overall. So nice there. And then we want to get some audio, just like we did in our SDI example, and therefore we'll put a little multicast address there for the audio. And just like we did in the video world, I'm going to have it go to another connection there on my switch, and audio comes right out. No need for a de-embedder, because as it was mentioned in Conor's presentation, in the ST2110 world, audio, video, ancillary data, all that, they're separate streams. They coexist peacefully. They're not inside of little packets on a frame-by-frame basis. I'm shorthanding the exact science there, but for our purposes here, I have the ability now to strip off just the audio from within inside the switch itself. I don't have to have a separate piece of hardware that de-embeds the audio or re-embeds the audio, as the case may be. It just comes off and goes where I need it to go. So right off the bat, I now have far fewer cables required, especially in the case of cameras and CCUs and things like that, because we're a bi-directional system that can hold many signals on one connection. And because they're independent streams, I don't have to have those off-the-shelf de-embedders hanging on to my beautiful router and all that. So much more elegant, we'll say, in the grand scheme of things because of that. But here's the big one that I love. The same exact scenario as before. I'll back up once again. We'll notice our camera 2 up there coming with this connection to input number 6. Someone comes along for reasons we don't understand and moves it over to input number 5. But the real beauty is this does have the intelligence to know that, because our monitor down there is looking for that stream address, that multicast IP address. Remember, before I started off this part of the presentation by saying thanks and being facetious about making me type in all these numbers, there's a value to that. That set it and forget it concept of typing in those multicast stream IDs, those IP addresses, if you will. That value is that now, when someone moves that cable, the signal can say, oh, I know that I'm supposed to go here. Or you could say that that monitor is subscribing to that address, and it knows, even though it's moved within the switch, where it needs to go to make it happen, where it needs to go get it. So what doesn't happen in the SDI world will happen here in the 2110 world, because it's IP based, not just a one-to-one connection base. So in short, an SDI system, it goes based on the connector, not based on the inherent data of the video signal or audio signal. In the 2110 world, it's based on the multicast address of what you have. In this case, that 239.20.1.2 address. So no matter where you move it on your switch, again, to any port, there's no ins and outs anymore. They're all ins and outs. No matter where you move that cable, it will find its way to the destination that it's supposed to go to. And again, no effort on your part. Nothing is required for you to go and make that happen. Once that connection is made, it will go and do it for you. So again, there's all kinds of cool things you can get in there and program to your heart's desire, or you don't have to do any of that and just let it happen by itself. The inherent capabilities of an IP-based system. All right. So now everything's fine. We're looking good. The connection has been reestablished internally based on that IP address, and we're all nice and happy. But invariably, people might think, I'm kind of used to SDI, and I really like the fact that I've got, dedicated cables for return video, and one for teleprompter, and one for reference. And of course, there's video and audio, and all those kinds of things coming one way and the other things going the other way. That's all very nice. I can really see that. It makes sense to me. Love it, love it. Super cool. So I really don't want to put all my eggs in one basket. I haven't had to do that before. I don't want to do it now. Some people might think that. But I would say you have been doing that for about a quarter of a century. Anybody want to hazard a guess for those that weren't privy to the presentation yesterday, what technology that's been in existence for about a quarter century, 25 years, has essentially taken all these great signals, some going one way, some going the other, putting into a fiber-based system and connecting different devices? Yes, SMPTE hybrid fiber cable. That's exactly what it does. It's exactly what it's been doing all these years. And while you've got the LEMO connector on one side there, the other side, in some cases, again, 2 fiber cables, exactly the same as 2110. So the concept of 2110 has been in existence for a very long time. A bidirectional signal, one thing going one way, other things coming the other way, interconnecting over very long distances, in some cases miles and all that, in a way that makes your life super easy. And again, lots of different kinds of signals. So this again has been around for some time. The only thing that's different is essentially it's proprietary. A Panasonic camera hooks up to a Panasonic CCU, and you wouldn't therefore hook up a Sony camera to a Grass Valley CCU. So there's a proprietary nature there that's necessary, whereas in the glorious world of 2110, it's all open, as Conor had mentioned. That's the great genius of it, is that again, anybody can attach a 2110 endpoint, essentially a monitor, a switcher, or whatever, to a source from another company, utilizing the same kind of technology, but again, just based on that stream address, that IP address. It doesn't have to be one manufacturer's device to the same manufacturer's device. So again, a wide open standard using basic technology that's been around for 25 plus years. So if again, you have any trepidation about making the move to 2110, just know that you probably already made it if you're in the broadcast world. In fact, there's almost nothing that you could think of on television that it's a live sporting event or we'll say a Dancing with the Stars type show or the news, or whatever, that has not been transported over a SMPTE hybrid fiber cable. So just about everything in the broadcast world has been doing this for quite some time. All right, now let's turn our attention to a practical scenario. So this is a broadcaster in the DC area. They do a couple of major sports teams out of Capital One Arena, and they've got 4 switchers because they do a lot of different shows, in some cases at the same time, because again, 2 different franchises. And each one has a lot of inputs, 128 apiece. Then outputs, add them all up, and you get somewhere in the neighborhood of 672 signals. 672. Again, this is just going into the switcher from the router and out of the switchers into the router. So the router switcher connection doesn't count all the camera stuff, doesn't count all the things related to servers and all the displays and endpoint. None of that stuff is counted here. And they were thinking about going to the SDI way of doing things, the traditional way, the safe choice, that sort of thing. But then they thought, you know, if I have 672 signals in an SDI environment, how many cables would I need? How many SDI cables, if we'll call it that, would I need to allow me to use 672 signals? Anybody want to throw out the super complex answer? 672. It's a 1-to-1 relationship. You have 1 camera and 1 monitor, 1 cable. 2 cameras and 2 monitors, 2 cables. On and on it goes. It's a simple thing. However many signals you have is the number of cables you need. Now, while the math is simple, actually building it is not so easy. Who here would want to basically cut, boot, label, and terminate times 2, 672 cables? A little tedious, not to mention expensive. There's a lot of labor that goes into that, not to mention the cables themselves, as we mentioned at the top of the presentation, kind of expensive. Copper is at their core. So, not super easy. And then you might invest a fortune, as we've seen tons of people do, in the world's best 3G SDI cable. And then 2 years later, somebody says, you know what would be really good? 12G. And you're like, you know what would be really expensive? Switching out that 3G cable that cannot handle the 12G now to make it 12G compatible. And if you get the really good 12G cable that lasts, or that's able to run, I should say, the longest possible distances, you know, that stuff is pretty big. It's about 3/8 of an inch in diameter for 1 signal going in 1 direction. So not super easy. And again, there's all kinds of things to love about SDI. There's all kinds of great things to love about the wonderful companies that make SDI cables. It's still the backbone of the industry. But once again, it's not perfect, which is why we're here to learn about essentially one possible successor, 2110. All right, so this particular broadcaster did not want to terminate just the connection between the switcher and or switchers, I should say, and the router with 672 cables, and they chose to go with 2110, as you might imagine. And because one of the great things about 2110, we don't have that one signal to one cable concept. We can once again gang up many signals on a single cable if you want to. And in this case, 672 signals, the same 672 that we had before, now equal 16 cables. So again, the idea, do you want to terminate 672 cables and all that, or 16? Not to mention the cost savings, the engineering savings, and having to pay people to do all that kind of stuff. This, for them, was the much more elegant choice. So a lot of great things about it. Is this for everybody? I'm sure there's lots of folks that would say, I prefer it the old way. I want to be able to go grab that one signal from camera 5 and put my hand on it, and that's that. And again, there's value to that. But for those who want the more, so we'll say, elegant approach where you don't have thousands of cables running amongst your building, 2110 has a lot of benefits, a lot of cool capabilities. Okay. Now, the switcher in that particular case for that big sports broadcaster in DC, the one that we're using here today, and the one that basically was one of the first of the native 2110 switchers, is called KAIROS. So it's capable of doing a lot of things that most switchers do, and it's got a lot of things that a lot of switchers have never done before. And if we think about all the things the switcher does, most of it, for the cool part, we'll say, is creative. For example, if you have a router is the opposite of creative. Its job is to get a signal from here to there. But a router and a switcher have a lot in common. The one thing that separates a switcher from a router is the creative capability. You have a switcher, you buy one, you use a switcher to make a creative show, not just send a signal from point A to point B, to overlay graphics, to do cool transitions, to color correct, to manipulate, to manage, to improve your show, to improve just a collection of signals and make it into a super cool broadcast. That's what a switcher does. That's based on its creative capability. And within KAIROS, we have, I think, the most cool capability from a creative standpoint of any switcher that exists in the world today. So we normally measure the creative capability of a switcher, two things. Mostly two things, there's a whole bunch, but for the most part, how many MEs do you have? And how many keyers do those MEs have? And typically it's 4 MEs, maybe 16 keyers, things like that. But invariably, we've seen this happen time and time again. Somebody buys a 4 ME switcher with in total 16 keyers, and then the next time the producer or director walks in, they say, all right, I want to use that 5th ME. Oh, I only have 4. Okay, well, just get the 5th. That means getting rid of this one and buying another. Fantastic. You can't just add another one? Sometimes yes, sometimes no. All right, well, then at least give me a few more keyers. Sorry, I already maxed out. It's no fun to basically sit there after making a huge investment in a really nice switcher, and then as the TD, have to tell the director or producer, sorry, I just don't have enough resources to do that. But you just spent 500 grand on the switcher. That's right. You can't get one more keyer. No. All right. But what if you didn't have a fixed limit to the number of keyers or MEs or things like that? What if I had the ability to essentially take advantage of GPU technology, again, a reference to Conor's presentation, and say, all right, if I want to add another key or another ME, if I wanted to keep that going until I exhaust the capacity that is of the GPU, why can I do that? That's why people buy KAIROS for the most part, because it has no fixed limits for the number of MEs or keyers. In other words, it's creative capability. And again, along the way, it does all kinds of cool things like natively work with 2110. You can throw an SDI, NDI, SRT, the whole alphabet soup of different flavors that you can get to in the production world, and lots of other cool things, up to and including the fact that it's outputting now a streaming thing. Everyone watching at home per se or work is watching the streaming output from KAIROS. There's this projection, which is coming from KAIROS. There's a video wall behind me. You'll see it later, also coming from KAIROS, all at the same time. So the video wall, in fact, is an unusual aspect ratio, which is different than the live stream and the projected output here. So lots of capabilities to do lots of things that used to be the province of different machines, now can be in one machine, one big, elegant switcher that do all that stuff for you. But one of my favorite things about it, again, hearkening back to that little bit of effort we put in to make our 2110 system. Remember, I made several humorous references to typing in your IP addresses that represent the various video and audio streams and things like that. Well, one last time to harken back to that. Here we are with that same exact scenario, the 2 cameras up at top. In the 2110 world, our switch in the middle. And in this case, I've simplified it by having a single KAIROS at the bottom. And I've really oversimplified it by having, or pretending in this scenario, there's just one input to the switcher. We've got 2 cameras, but only one input to the switcher. In the SDI world, you basically say, well, you lose out. Or you sub-route at your router to put in the exact signal that you want. But it requires some effort, usually, on the part of the TD to say, all right, my router, I want camera 2 to be in my switcher now. No, camera 1. And then I go to my switcher and I do my part there. In other words, a 2-step approach, if you will. But what if, sort of like that whole idea where, remember we moved the cable in my analogy of someone going in there for reasons we don't understand and swapping the port and all this stuff, and in the 2110 world, because of that IP address, it was able to find it? What if we could make use of the IP address to simplify that process? Most switchers, the high end, don't have enough inputs compared to how many sources they want to talk to. It's a common thing, once again, to have, for example, 50 inputs on your switcher, but you've got 70 sources. You either have to forget about some of those sources, or you have to sub-route them, as the term goes, using something called tie lines. So again, that's possible. It happens all the time. People at home don't notice it, but the TD works very hard to sub-route signals and then tell their switcher what to do. So what if we could skip that whole middle process, achieve the same goal, fewer inputs on the switcher than we have in total in our network, but I want to not have to go to 2 steps to make that work. So right now, camera 2, as you might notice down below, is tallied red, it's on the air, and therefore camera number 2 is on the air. But all I want to do now is push the camera 1 button, and in doing so, it will automatically switch that route over and put camera 1 signal on the air. Now, there's a whole bunch of details I'm going to sidestep for time purposes, but essentially, I can go back and forth all the time, and simply by pushing that 1 button on the switcher that I would normally do as the TD, it's finding that signal within the switch itself. It's self-routing, if you will. No 2-step process to worry about pushing something here on a router and then doing it on the switcher. I'm just touching the switcher and doing my normal thing, and it's able to find it. Now, again, this is a somewhat ludicrous example to try and make the point. Obviously, you probably have 80 signals coming in and maybe another 4 or 20 signals you get, we'll say, sparse use out of. You don't use that much on this sort of thing. You don't have to spend the extra money to have a dedicated input on your switcher. But I still want to use it once in a while. This is for that scenario. The ability to bring in sources you don't always use and conserve money by not having more inputs on your switcher, but not have to go to a lot of effort to do it. I don't have to go program some router while simultaneously switching my show on the air. I just want the switcher to do it for me. So now I can go back and forth all day long. In my example here, you might see that little red line in the middle of my switch, changing back and forth, and away we go. So think of that happening, not just with 1 input and 2 sources, but again, dozens of sources you don't often use, in addition to the 50 sources you use all the time, all that stuff. It's all figuring it out for you. And as I joked at the beginning, no programming required. You basically just tell it, I want this to be an on-demand source in the KAIROS menu, and away it goes. You don't have to think about it. In fact, ultimately, if your engineer sets up the switcher, this is transparent to the TD. TD doesn't even know this is happening. So, super cool process to make your life easy. And again, ultimately as a manufacturer, that's what our job is all about. To give you the highest quality production tools while simultaneously making your life easy. So that is the end of my presentation. We'll open it up to questions if anybody has any from here or in streaming land. And in the meantime, you can look at this wonderful QR code and hope that you'll follow it to all these cool products we've been talking about. All right.